Good morning, third grade. Today we're going to begin learning about Get More story problems. Our targets for today are: I can identify the parts and whole in a Get More story problem, and I can solve Get More story problems with a missing whole using a bar diagram. A Get More story problem is a story problem where there is one amount. Then a Get More action happens. Finally, the amount increases or becomes bigger. You can see here an example of what a Get More story problem might look like. First, there is one amount. Here you can see that there are 3 teddy bears in a wagon. Then a Get More action happens. You can see that this girl is bringing 2 more teddy bears to the wagon. The amount increases or becomes greater. You can see now, after the girl has brought 2 more teddy bears, that there are 5 teddy bears in the wagon, which is more than there were at the beginning. This is a Get More problem because there's an amount, a Get More action happens, and the amount increases or becomes larger. You have learned about Get More problems in first grade and second grade. In third grade, we'll learn about them again and do trickier Get More problems with bigger numbers. Get More problems always have a Get More action. A Get More action is any action that makes the total amount increase or get bigger. In the example we were just looking at, the Get More action was to bring 2 more teddy bears. When the girl brings 2 more teddy bears to the wagon, it makes the number of teddy bears increase or get bigger. So our Get More action in this problem would be to bring. Some other Get More actions that we commonly see in Get More story problems would be the action bought, got, found, made, earned. All of these actions are Get More actions because they make the amount increase after they happen. Remember, these are just a few examples of Get More actions. There are lots more Get More actions. I bet you could even think of 1 or 2 right now. A Get More action is any action that makes the total amount increase or get bigger. When we solve Get More story problems, we always use a bar diagram to represent the problem. This is a bar diagram. A bar diagram has parts and a whole. The parts go inside of the bar diagram. Oftentimes, there are 2 parts, although there can be more. You'll see this example bar diagram has 2 parts, one here and one here. The whole goes in the top. You can see that here. There is 1 whole. In a Get More problem, there is 1 whole in a bar diagram. You know from first grade and second grade that part plus part equals whole. You can see when you look at the bar diagram that the 2 parts are the same size as the whole because the parts together equal the whole. As we just discussed, part plus part equals whole. I'm sure you remember this from first and second grade. Part plus part equals whole. The 2 parts, when you add them together, are equal to or the same as the whole. Here we can see an example of that. Here, 2 is a part. 8 is also a part. I know 2 and 8 are parts because they are inside of the bar diagram. Here, 10 is our whole. I know that 10 is the whole because it is at the top of the bar diagram. Well, I know that part plus part equals whole. I also know that 2 plus 8 equals 10. Here you can see part plus part equals whole because the 2 parts, 2 and 8, equal the whole. Let's look at another example together. Here you can see we have 2 parts, 6 and 3. The whole, however, we don't know. We would say that the whole is unknown. In third grade, we use letters to represent the unknown information in a story problem. We will usually use the letter N, although you could use any letter at all. We'll use the letter N to represent the unknown. So in this problem, you can see that we know the part 6, we know the part 3, but the whole N is unknown. When I want to find an unknown whole, I need to add, because part plus part equals whole. If I add the two parts together, it will tell me the whole, even if I don't know it right away. So let's try this. 6 plus 3 equals n, because part plus part equals whole. Well, think in your brain, what does 6 plus 3 equal? When we figure out what 6 plus 3 equals, it will tell us the whole, or what n equals. What is 6 plus 3? You're right. 6 plus 3 is 9, so n equals 9. You have just found the unknown whole in this bar diagram by adding part plus part, which equals the whole. Awesome job, third grade. Let's talk a little bit more about get more problems. In a get more problem, there is one amount. You already know that. We call this amount the starting amount because it's the amount that you start with. The starting amount in a get more problem is a part. Then you know that in a get more problem, an action happens. We call this the get more amount. The get more amount is also a part. Finally, the amount increases or becomes greater. We call this the result amount because result means total. So this is the total amount. The result amount or total amount is the whole because it is all of the amounts put together. So let's think about this in terms of our teddy bear problem. The starting amount is 3 because there were 3 teddy bears in the wagon to start with. This would be a part. Our get more amount would be 2 because the girl brings 2 more teddy bears to the wagon. These 2 more teddy bears she brings to the wagon are the get more amount, and they are also a part. So we know that the 3 teddy bears in the wagon to start with is a part. The 2 teddy bears the girl brings is also a part. Then we see that we end up with 5 total teddy bears in the wagon. This is the result amount, or the total amount after the action happens. This is the whole, because it is all of the teddy bears. So again, in a get more problem, we have a starting amount that is the part, we have a get more amount that is the part, and then we have a whole or total, which is the whole. So let's think about how we would put our information in a get more problem into a bar diagram. Well, we know that the amount we start with, the starting amount, is a part. So it would go inside of the bar diagram. You could put it on either side of the bar diagram because the parts can go in either place as long as they're inside of the bar diagram. The get more action would also be a part, so it also goes inside of the bar diagram. The result amount is the whole, so it goes on the top. With this problem, we know that there were 3 teddy bears to start with. Since this is the starting amount and it is a part, I would put it inside of the bar diagram. 3 teddy bears. Then let's think about the get more amount. The get more amount in this problem was 2 because the girl brought 2 more teddy bears to the wagon. I know that that is also a part, so I will also put that inside of the bar diagram. Here you can see I have 2 brings more teddy bears. It's the teddy bears the girl brought. Then third grade, finally, there's the whole. Think about how many total teddy bears the girl ended up with in the wagon. What would we put for the whole? Yes, the whole is 5 total teddy bears, or 5 teddy bears in all. You can see, third grade, how we would put a get more problem into a bar diagram. The starting amount is a part, the get more amount is a part, and the result amount, or the total at the end, is the whole. Sometimes, third grade, we're going to have get more problems where we do not know the result or the total. Those problems might look like this. There is an amount, 3 teddy bears in the wagon. A get more action happens. The girl brings 2 more. The amount increases, but we do not know the answer. The unknown piece of information is the whole. It's the total. When we want to solve a get more problem where we do not know the whole, we use a bar diagram to help us. We start by putting the information in the bar diagram. We know that there are 3 teddy bears to start with. That's our starting amount. So we would put 3 teddy bears as a part. We know that the get more amount is 2 more teddy bears the girl brings. That is also a part, so we put that inside of the bar diagram. Now, here we know that the result amount would be how many total teddy bears there are in the wagon, or teddy bears in all. The only thing is we don't know what that number is, so we have an unknown. We would say that there are n teddy bears in all, because remember, we use the letter n to represent the unknown information. Let's think about how we would solve this problem. When the unknown number is the whole, we have to add to find the answer. We can see that our unknown information, the n information, is teddy bears in all. We do not know the whole, so I need to add because part plus part equals whole. I need to equal the whole or find the whole, so I'm going to add part plus part to figure out my unknown whole. In this problem, that would look like 3 plus 2. Because one of my parts is 3 teddy bears and the other part is 2 more teddy bears. 3 plus 2 equals n, my unknown. Think in your brain, 3rd grade. What is 3 plus 2? When you figured out what 3 plus 2 equals, you'll know the answer to the problem. You'll know what n equals. What is 3 plus 2? You're right. 3 plus 2 is 5, so n equals 5. Awesome job, 3rd grade, using the information in a bar diagram to find the answer to a problem. Let's go ahead and quickly talk about the problem-solving process. Anytime you're solving a story problem, whether it's an addition story problem or a subtraction story problem, or even 3rd grade, a multiplication or division story problem later in the year, you'll use this same problem-solving process. We have 4 steps to solving a story problem. First, we have to read and understand the problem. We need to figure out, what do I know? And also, what am I trying to find out? Or what is the unknown in the problem? Then 3rd grade, we have to plan. We need to determine the problem type if we don't already know it, although today you know that we're solving get more problems. And then we need to organize the information. When we're solving a get more problem, we organize our information in a bar diagram. 3rd, we solve the problem. We choose the operation. Do I add or subtract? Later in the year, you'll have to even think, do I multiply or do I divide? And then once you've figured out what you need to do to solve it, you solve the problem. The 4th and final step is to look back and check. Look at your work and at your answer and think to yourself, is my answer reasonable? We're going to solve a story problem today together called Jack's Toy Cars. Let's look at the story problem together one time. Jack had 34 toy cars. Then his grandpa gave him 8 more for his birthday. What is the total number of toy cars Jack has now? Let's think about that problem-solving process again. What do we need to do first? Oh yeah, we need to read and understand the problem. Oftentimes, 3rd grade, you will read a story problem 3 or 4 or even more times to make sure you fully understand it. That's part of being a good mathematician, is to read the problem multiple times to make sure that you know what it is that you know what the story problem's telling you. And also, what are you trying to find out? What is the unknown? Let's go ahead and do step 1 of our problem-solving process, reading and understanding the problem. So, Jack had 34 toy cars. Then his grandpa gave him 8 more for his birthday. What is the total number of toy cars Jack has now? Think about, what are the pieces of information they tell us in the story problem? What do we already know? Well, one piece of information is that Jack had 34 toy cars. That's one piece of information. Let's read the problem together again and see if we can find the second piece of information. Jack had 34 toy cars. Then his grandpa gave him 8 more for his birthday. What is the total number of toy cars Jack has now? I think I see that second piece of information. It has a number in it, so it's a little bit easy to see. Oh, yes, his grandpa gave him 8 more. That would be the other piece of information. One piece of information we know is that Jack had 34 toy cars. The other piece of information we know is that his grandpa gave him 8 more. Let's go ahead and now think about, what is it that we're trying to find out? What is the question asking? What is the unknown? Oh, I can see the question because it's got a question mark at the end of it. I can see that the question is, what is the total number of toy cars Jack has now? In 3rd grade, we circle the information that we know, and we underline the question. This way, it's easy for us to tell what is information that we know, it's circled, and what is the question, because it's underlined. So we know we're trying to find out what is the total number of cars Jack has now. Let's go ahead and think about these a little bit more so that we can figure out exactly what are the wholes and what are the parts. Oh yes, I see here that Jack had 34 toy cars. I highlighted this keyword had because it's helping me know it's how many he used to have, not how many he has now. It's how many he had or how many he started with. This is my starting amount. It's a part because it's not the total number of cars he has now. It's how many he used to have or started with. This is a part. Now look at the second piece of information. Gave him more. Do you see any key words that help you know if this is a whole or a part? We've already found our starting amount. What keywords are helping us here? The keywords that help me is the word gave. Gave is a get more action. After this action happens, his amount will increase. When someone gives you something, it makes the amount you have greater. It makes you have more of that item. Since this is my get more action, that tells me that this is my get more amount. It is also a part. If both pieces of information are the part, that probably means that the question is asking about my whole. But let's go ahead and look at the question and see if there are any keywords that help us know that it is in fact asking us to find the whole. The question says, what is the total number of toy cars Jack has now? Ooh, I'm seeing a key word that tells me that this question is asking us to find the whole. The words total number of toy cars tells me that this is the whole. It's the result amount. It's how many Jack ends up with after he's given more, and it's the total or the whole. I can see now, without a doubt, this question is asking me about finding the whole or the result amount. Now, 3rd grade, that we have thoroughly read and understood this problem, we're ready for step 2 of the problem-solving process. We're ready to plan solving our problem. When we plan, we determine the problem type if we don't know it, but we know this is a get more problem, and then we organize the information in our bar diagram. I already know this is a get more problem. I know it's a get more problem because there's a get more action. His grandpa gave him more toy cars. Since I know that this is a get more problem, I know I'll use a bar diagram to organize my information with the 2 parts inside and the whole on the top. We're going to start by labeling both parts and the whole with words. I'm going to look at this first piece of information. Jack had 34 toy cars. I'm going to pick the words that I'm going to use to label this piece of information. Jack had 34 toy cars. I'm going to label this piece of information, this starting amount, toy cars Jack had, because it's telling me right here, this is the information about how many cars he had to start with. Let's think about the other part. The information for the other part is gave him more. The words I might use to describe this part in my bar diagram would be toy cars Grandpa gave. And finally, my whole. I need to think about the words I could use to label my whole. The question is asking, what is the total number of toy cars Jack has now? So the label for my whole might be total toy cars, because I know it's going to be all of the toy cars he has. Now, once I have my bar diagram labeled, then I'm ready to put the numbers and the N for unknown in my bar diagram. Let's go ahead and think about what numbers go with each of these pieces. Let's start with the part toy cars Jack had. Look back up at the story problem. How many toy cars did Jack have? Oh yeah, I see right here. Jack had 34 toy cars. So I'll put the number 34 here. 34 toy cars Jack had. Think about this second part. Look back up at the story problem. How many toy cars did Grandpa give Jack? How many toy cars did he give him? What's the number that goes with this piece of information? You're right. According to the story problem, Grandpa gave him 8 more. So 8 is the number that goes with this piece of information. 8 toy cars Grandpa gave. And finally, think about the whole. The whole is the question. It's what the story problem's asking about. So we don't actually know the number. It says, what is the total number of toy cars Jack has now? The story problem does not tell us this piece of information. It's what we're trying to find out. This is our unknown. Think, what did we decide we would label the unknown piece of information? What could we write down instead of a number, since we don't know the number yet? You're right. We decided we would use N to represent the unknown. So we will say N, total toy cars. Now that we have planned to solve our story problem using our bar diagram, let's go ahead and look back at our problem-solving process so we know what to do next. Oh yes, we've read and understood, we've planned, now it's time to solve. We need to choose the operation we're going to use, adding or subtracting, and then we need to actually solve the problem. Well, let's see here. I know that in this problem, we know the parts, 34 toy cars he had and 8 toy cars Grandpa gave him, and we do not know the whole, total toy cars. When we do not know the whole, but we know both parts, we know we're going to do part plus part to find the unknown whole. Part plus part equals whole. So we are going to add to solve this problem. Down where it says equations, I always write part plus part equals whole to remind myself that when I do not know the whole, I'm going to add. We are going to write our equation, and we're going to make sure and label each number so that we really know what we're doing. We can write the parts in either order. It doesn't matter what order you write the parts in. You could write 34 first or 8. You can write them either way, it doesn't matter. You already know that it doesn't matter the order of your parts. When you add them together, they'll equal the same thing. We're going to start with this part. Well, we know our number is 34. Now think, what would we label this 34? This is 34 what? You're right, it's 34 toy cars Jack had. So I'm going to make sure and label that number so that I'm really thinking about what this number means. 34 toy cars Jack had. I need to add that to my other part, seen here. 8 toy cars Grandpa gave. I'm going to write 34 toy cars Jack had plus 8. What would I label this 8? Think very carefully. What are the words that go with 8? This is 8 what? You're right. It's 8 toy cars Grandpa gave. So my equation so far looks like 34 toy cars Jack had plus the 8 toy cars Grandpa gave him equals, this is going to equal our whole or total. What will our whole or total be? Go ahead and look at the bar diagram to help you figure that out. What number should we write for the total? Remember, it's going to match the whole in the bar diagram. What words should we write for the whole? Remember, it's going to match the whole in the bar diagram. What would we write for our whole? You're right. We would write N for the number because we do not know it, it's unknown, and it's N total toy cars. We currently do not know the total number of toy cars Jack has because it doesn't tell us in the story problem. Now, when I want to add 34 plus 8, I know I'm going to write it vertically, so I'll do that. Here you can see I've written 34 plus 8 vertically with the ones place, the 4 and the 8, carefully lined up. I can see right away that 4 plus 8 is going to equal more than 10, so I'm going to use my make a 10 strategy to add the ones place. I know that 4 plus 8 equals 12, so I regroup my 10 and put my 2 in the answer in the ones place. Then I have 1 plus 3. 1 plus 3, of course, equals 4, so there's a 4 in my answer in the tens place. 34 plus 8 equals 42. So now I know that N equals 42. I always write that down here in my equation so that I know what N equals. Oh yes, N equals 42. Once I have determined what N equals, I also will add that to my bar diagram. Here you can see I've added N equals 42 to the bar diagram, showing that there are 42 total toy cars. The last thing I need to do to answer this problem is to actually write the answer in words. Just like how when you write an answer to a reading question, you restate the question and write in a complete sentence, we're going to restate the question and write in a complete sentence here. Our question is asking, what is the total number of toy cars Jack has now? Sometimes third graders just want to write the number answer, 42, but that would be incorrect because you didn't tell what this 42 means. The question is asking, what is the total number of toy cars Jack has now? We could say, Jack now has 42 toy cars. You can see that we've restated the question, Jack now has, and that we've told what this 42 means. This 42 is toy cars. So a complete answer would look like, Jack now has 42 toy cars. The very last step in our problem-solving process is to look back and check. We need to look at our work and our answer and make sure our answer is reasonable. Let's go ahead and do that. I'm going to look down here at my work. I can see that I've added 34 plus 8. 34 plus 8, I decided equaled 42. That makes sense because 34 is a part and 8 is a part. 42 is my whole and it's larger than both 34 and 8. Your whole should always be larger than your parts, so this makes sense. I'm also going to double check my answer that I wrote in words to make sure that it restates the question and is a complete sentence. Jack now has, yep, I've restated the question, 42 toy cars. Yes, this is a complete sentence that restates the question. Third grade, you have just solved your first third grade Get More problem with me. Tomorrow, we're going to learn how to solve Get More problems that have missing parts. I look forward to doing more math with you tomorrow.